So here is another question on graphical analysis of one-dimensional motion. So it is given that a car starts from rest and accelerates uniformly for 10 seconds and attains a velocity of 36 km per hour. It then runs at a constant velocity and is finally brought to rest in 50 meters with a constant deceleration. If the total distance covered by the car is 500 meters, find the value of acceleration, retardation and total time taken. So basically it is graphical analysis. We have to use the graphical approach to simplify the whole situation. So we'll be using velocity time graph, velocity and time as the appropriate choice of parameters for the two axes of this graph. This is here velocity in one axis, the y axis, and time in the other. So it is given that the car, it starts from rest, that is at t equals to 0, the velocity is 0. It starts uniformly, accelerates uniformly means the slope is constant, this, and it attains a velocity of 36 kilometers per hour. Now again we'll express everything in meters per second. 36 kilometers per hour is 36 into 1000 meters. 1 hour is equal to 3600 seconds. So it is basically 10 meters per second. So it is 10 meters per second. It attains a velocity of 10 meter per second. Then it runs at a constant velocity, that is slope is 0, constant velocity, no acceleration. This for a small certain period of time, and then it undergoes retardation. This is the whole situation. Now we will be dividing this whole velocity time graph into three parts. First is the acceleration phase. This, let's name it OA. This has a time of t1. Then we have the second phase, which is the constant velocity phase, from A to B. Let it be time t2. The time duration is t2. Then we have the deceleration phase. This is BC and this is t3. And remaining, this is here D and E. Now the distance covered in this acceleration phase is nothing but the area of the triangle OAD. Let it be S1. The distance or displacement undergone by the object during this constant velocity phase is nothing but the area under this rectangle ABD, which is S2. And then the distance covered during this deceleration phase is nothing but the area of this triangle EBC, that is S3. Now, according to the question, total distance, that is S1 plus S2 plus S3, is 500 meters. That then this S3, the distance covered in the retardation phase, is 50 meters. This. Now, first let us focus on S1. It is said that the car accelerates uniformly for 10 seconds. So here T1 is equal to 10 seconds. the area of the triangle OAD is equal to 1/2 base into height 1/2 into OA into AD, which is equal to the distance covered S1 in that phase. That is equal to 1/2 OA is equal to T1, AD is the velocity acquired, okay, the velocity acquired by the car, that is equal to 10 meters per second. Simply substituting the values, 1/2 into 10, that is equal to 50 meters. So S1 is equal to 50 meters. Okay, this. Then S2, we know S1 plus S2 plus S3 is equal to 500 meters. S1 we have calculated is 50 meters, S3 is given is 50 meters, so S2 is 500 minus 50 plus 50, which is equal to 400 meters. S2 is 400 meters. Now S2 is nothing but the area of the rectangle ABD. S2 is the area of the rectangle ABDE, which is equal to AB into AD. AB into AD. AB is nothing but T2. AD is nothing but the velocity acquired by the car. That is equal to T2 into 10 meters per second. That is equal to 400, which we have calculated here. That implies T2 is equal to 400 by 10, which is equal to how much? 40 seconds. T2 is equal to 40 seconds. T1 was given already 10 seconds. T2 is 40 seconds. Then the last phase. Here S3 is already given, it is 50 meters. The area of the triangle, that is EBC, is nothing but 1/2 base into height, that is BC into BE. Okay, BC into BE. BE is nothing but the velocity of the car, that is 10 meters per second. That is the velocity of the car. BE is equal to AD, which is equal to the velocity of the car, 10 meters per second. BC is nothing but T3. BC is nothing but T3. So that is equal to 1/2 into T3 into BE, which is equal to 10 meter per second. That is equal to 50 meters. That is equal to S3. So that implies T3 is equal to 50 into 2 by 10, which is equal to 10 seconds. So T3 is equal to 10 seconds. The retardation phase, it takes total time T3 is equal to 10 seconds. Now the total time taken, which is asked in the question, which is equal to T1 plus T2 plus T3, which is equal to T1 already given 10 seconds, T2 we have calculated 40 seconds, plus T3 we have again calculated 10 seconds, that is equal to 60 seconds, the total time. Next is the acceleration and retardation. Now for the acceleration, let this angle be alpha, okay, for acceleration. Now acceleration is equal to the slope of this OD curve during this acceleration phase in the first phase. So that is equal to tan alpha, which is equal to AD by OA. AD is nothing but 10 meter per second, the velocity, the final velocity, and OA is the total time taken, T1, which is given 10 seconds. This is 10 meter per second. So that is equal to 1 meter per second square. That is the acceleration. Okay, acceleration is 1 meter per second square. That is the acceleration. Then for retardation, here let this angle be beta. So here retardation will be, let me use a different ink here. Okay, retardation, I'm writing it here. Okay, retardation is tan beta, retardation, that's why negative sign, that will be equal to BE by BC, BE by BC, which is equal to, again B is equal to minus 10 meter per second, BC is equal to T3, which we have calculated, T3 is equal to 10 seconds, T3 is equal to 10 seconds, which we have calculated. 10 seconds, that is equal to minus 1 meter per second square. So retardation is also magnitude wise it is same, but negative sign comes because it is getting retarded. Okay, velocity is decreasing. So retardation is equal to minus 1 meters per second square. So the parameters which were asked, acceleration plus 1 meter per second square, retardation minus 1 meter per second square, magnitude wise same, direction wise because it is decreasing, that's why it is minus the retardation, and the total time taken T1 plus T2 plus T3, that is equal to 60 seconds. This. Okay, so again a very good question related to graphical analysis of one-dimensional motion.